Hello everyone and welcome to the Factor Four area located on the BCIT Burnaby campus. Today we're here to talk about energy and energy management, and we're going to do that while doing a tour of the A-Fresh House, one of the demonstration buildings that we have located inside the Factor Four area. Now, before we start the tour, it's important to remember that energy and energy management is all about supply and demand, and that usually you should look at demand first and supply second. But in this case, we're going to start with looking at the supply and the supply equipment, because everything that we have in the house, or almost everything that we have in the house generating electricity for us, is located outside. So let's start the tour with us looking at supply. Okay, so the first technology we're going to look at today is photovoltaic panels, also called solar panels. So what you see here is a set of 6 panels. They are 190 watts each, so we have roughly 1.2 kilowatt capacity here. They're all facing south. They're all adjusted at an angle that makes sense with the latitude of the Burnaby campus. You can't see it from here, but we also have another array facing east. Most of the time you wouldn't want your panels to face east, because you don't get as much sun as you do for fixed panels facing south. But in this case we also have an array on the east side with a 1.9 kilowatt capacity. So we have roughly 3 kilowatt of solar panels installed. Now, depending on where you install 3 kilowatt, you'll get different amounts of energy. Either, if you compare California to BC, for example, obviously you're going to get more energy per kilowatt in California. There are ways to calculate these numbers, and Arcan has a really good website where you can actually find your location, and based on number of daylight hours and average and your latitude, you'll know roughly how much you should get. At this location we should expect about 1,000 kilowatt hour per kilowatt installed per year. In our case, because some of our panels are actually facing east, we're getting roughly between 2,000 and 3,000 kilowatt hour per year from the solar panel. So that's one way we're generating electricity for the house. Obviously that's not enough. We're going to look at the second source of on-site production, the wind turbine located at the back of the house. So let's move to the back here. Okay, so we're now at the back of the house looking at our vertical axis wind turbine. This technology that we have here is rated at 5 kilowatt when the wind blows at about 12 meters per second. But what's interesting about it is that it has the capacity to produce some electricity at very low wind speed, at wind speed on paper as low as 2 meters per second. So the outside component of the tour is mainly about supply and how we are generating energy for the house. We've talked so far about the solar panels, and we've talked about the wind turbine, and these are all technologies that are generating electricity. But we also have something that falls somewhere in between demand and supply. We're not really generating energy, and in this case the energy is not electricity, it's actually heat. It's our Geo-Exchange System. We'll talk a bit more about it when we're inside, but for now you need to know that the heating and cooling of the house is done through this Geo-Exchange System. We have a heat pump, water to water pump inside. But before we go inside, I wanted to show you what the piping system that goes into the ground look like. So what you do typically, well, you have two different technologies. You have horizontal and vertical Geo-Exchange System. What we have here is a vertical system. What you do typically is you drill a borehole to a certain depth with this type of soil and this type of installation, probably around 200 feet deep. And once your hole has been drilled, you will insert 2 pipes that are connected at the bottom with an elbow, so that what you can do is inject a liquid deep into the ground, so that when it comes out back in the return line, it's actually, for example, in the winter, a little bit warmer than when it came in. And so this one is not attached to the house. We added an extra one at the back so that we could come here with students and do some experiments. But if it was connected to the house, you would also have a set of pipes going horizontal, very shallow under the ground into the house. And it is this horizontal pipe that would connect to the heat pump that I'll show you later when we do the tour of the mechanical room. So another piece of equipment we wanted to show you today is the electric vehicle charging station. We treat that in our tour as part of the supply because the intent is that one day we could actually use the energy stored in the batteries of the car to power the house at night when you don't need the car but you need energy in the house. So obviously it's not a source of supply in itself, but eventually it could become one, having this connection with some energy being stored in the car. But besides that, it's a regular charging station. It's a level 2 station, yeah, it's simply used to recharge the batteries of your EV car. So we're now done with the outside tour of the house, and we're currently inside the mechanical room of the house where most of the equipment is located. We talked about the fact that energy management is all about managing your supply and managing your demand. Most of the equipment you'll see here is about demand side management, but there's still two things that is linked to the supply that I would like to show you. The inner component of the Geo-Exchange System and our on-demand fuel cell. If we start with the Geo-Exchange, when we were outside, we look at the boreholes and where the pipes were going in the ground to get the heat from down deep in the ground. But you also need to bring the heat inside the house, and so you have a series of pipe which in a normal house wouldn't look as complex as this. This is meant for research. There's 9 modes of operation to our system, but typically you would have a very simple schematic where you only had 2 pipes, one for the supply, one for the return. And the main component of the Geo-Exchange System is the heat pump, in this case a water-to-water heat pump that takes the gain in temperature that you got from the ground and elevates it to a temperature that is high enough to be meaningful and allow you to heat the inside of the house and allow you to heat the domestic hot water. And so the last component that we have in the house that is linked to supply is our fuel cell. It's a on-demand fuel cell, which means that we don't have any storage for hydrogen. We actually get our hydrogen from our natural gas provided by FortisBC. Natural gas being methane, being CH4, there's a lot of hydrogen in it. So we have a reformer that is able to split the molecules to get the hydrogen separated from the carbon. There's an exhaust here that gets the carbon and the carbon dioxide exhausted. And then the hydrogen gets run through the fuel cell, creates electricity, and the electricity is sent to our grid box system, which I will tell you more about later. The last thing you need to know about this component is that there's a lot of heat generated through the process, and so this device is actually a combined heat and power system where we have a 500 watt capacity to produce electricity, but we also have 1 kilowatt capacity to recover heat and send the heat into a hot water tank where we can store it and use it later for other purposes in the house. Okay, so we're now done talking about the supply, energy supply equipment located in the house. We're now going to talk about a system, we call it our energy management box. It's a grid point system that does the liaison between the supply and the demand. So what this is really, it's a computer, an inverter, and a set of batteries. And it's a central location that receives all the electricity that we produce in the house. The electricity from the solar panels, the electricity from the wind turbine, and the electricity from the fuel cell. And it makes decisions about what to do with it. So it can keep the electricity in DC and store it in our batteries. We have a set of acid lead batteries. Store it there and keep it for later when there's a real need. It can take the DC current and through the inverter convert it to an AC current and send it to the house where there's a need, whether it is the various appliances that we have, the lights or any of the plug loads. Or you could actually also convert it into an AC current and send it back into the grid and sell the excess electricity that we have to BC Hydro. So really this is the brain of all the systems that we have in the house, because It decides what to do with what, and it also helps us manage the demand inside the house. And so the grid point system manages our supply. We've talked about our own supply, the solar panels, the wind turbine, and the fuel cell. It's important to note that it also manages the supply coming from the main grid, from BC Hydro. So all the electricity that we buy actually runs through the grid point system and goes through the same decision-making process as all the other electricity that we produce on site. So last but not least, we have a series of smart meters. It's important to know that in our definition, a smart meter is a meter that does two things more than a regular meter. First, it's capable of measuring electricity flowing in two directions, so electricity you're buying from the grid, but also electricity that you're selling back to the grid. And the other thing is it's capable of sharing on a real-time basis data with either the user or the utility, either by sending the data through cables and internet, or through wireless and internet. We're testing different technologies here. Obviously, in a regular house, you would only have one meter. Okay, so we're now inside the house. We spent most of our tour so far talking about supply. We've talked a little bit about demand, looking at the smart meters and the grid point system that was connecting both the supply and demand. But now that we're inside the house, we're actually going to focus only on demand, because this is where we're using the electricity. The first set of equipment I want to mention is our series of smart appliances. So when you are managing energy, the first thing you want to do is manage demand, because there's no point in producing electricity at a fairly expensive rate for electricity that you're actually going to waste later. So on a demand side the point of view for these appliances, they are all Energy Star rated, which means that they don't use much electricity for the service that they are rendering. So that's one thing. But when you are managing demand, you're not necessarily only managing how much energy you're using, but you're also trying to manage when you're using it, so that in partnership with your utility, you're helping them avoid having peaks, which means that it helps them avoid having to build overcapacity for those peak times, which means that in the end your rates should be maintained lower and everyone is a winner. So in this case, these smart appliances are helping you manage your demand, both by being efficient, but also by responding to signals that can be sent from the utility to your smart meter, to your appliance. The smart appliances that you see in this house are GE products. They are prototypes, but they are all basically talking to your smart meter, receiving signals about what's going on in the province right now. If we want to talk a little bit more about managing demand, not from a time perspective, but from a consumption perspective, the house is fully equipped with LED lights. When you're doing these kinds of retrofit in a residential building, it's pretty straightforward, because the products in the market are all meant to be one-on-one replacement screw-in bulbs. You have a flood type bulb that is actually 6 watt. You have a regular type bulb that is a 7-watt bulb, and then you have the halogen replacement that is a 10-watt replacement. And so if we look at all the fixtures we have in the house, they're all very energy efficient by having a low wattage but still providing the amount of light that we need in the house.